Hello and welcome to another one of these ADD videos. We're going to take a quick look at the concept of area of polar graphing. The main thing here is for you to know what your tangents at the pole are, which are going to be your bounds usually, and to also know what your boundary is, which is going to be your R. Tangent pole and then your boundary. For some of the basic shapes like circles and stuff, I mean, you can use pi r squared. Geometry is okay. Don't forget what you learned. Always use what you can to make your life easier. But let's say we have that rose petal example we did in the graphing. Well, in something like this, what you want to do, let's say if you were asked to do all three petals, you could either go from 0 to this intersecting line right here, or midpoint line, times it times 2, and then times 3 if you need all three petals, or you could go from 0 to pi over 3, the tangents at the pole. Okay, and you would use this R as your theta value. So, looking at something like that, I would like to use symmetry, because when you use symmetry, you can cancel the 2 and the half. And it would be, if I'm doing symmetry, I have to go to that midpoint, right? If you remember this midpoint, or if it's been a while since you've watched the area video, let's see, where did I find that midpoint? Right here. These guys right here. So that would be pi over 6. That midpoint right here is theta equals pi over 6. So I'm going from 0, the tangent at the pole, to pi over 6. And what's the boundary right there? Let's use a different color to stand out. Boundary is that rose petal. There's nothing else. Okay. Why am I emphasizing the boundary? Well, there will be area common, area outside but not inside, stuff like that that you'll have to do. So make sure you are aware of what is what. If you have to expand your graph, make it bigger, do so. So that graph is 4 sine 3 theta, and it was squared d theta. Let's go ahead and knock out this integral. It would be 0 to pi over 6, 16 sine square root of 3 theta d theta. For something like this, you're going to have to use the power reduction. So if we have sine squared of whatever, that's equal to 1 minus cosine 2 whatever over 2. And if it was cosine squared, the only difference is it would be a plus sign between them. So we have the 16 coming out in front. And then we have 1 minus cosine 6 theta all over 2. So then if we did 16, 0 pi 6, 1/2, and then minus 1/2 again. There should be d theta there technically. Cosine of 6 theta d theta. The integral of d theta is just going to be 1/2 theta. The 16's times everything. And that's evaluated between these two bounds. Minus 1/2. That's going to be, if you take the derivative of sine, you get a positive cosine. So to get a negative cosine, we need a negative sine. And then if you were to go off to the side and do u equals 6 theta, du equals 60 theta, you would need 1/6 to make that happen, right? Those of you that are familiar with your trig integrals, it's okay if you just went ahead and put a times 6 and made that a 12 down there. Sine 6 theta. Plus c, nope, no plus c, because this is a defined integral. And then we have 1/2 times pi over 6 minus 0 is going to be 0, minus 1/12 sine of pi sine of pi, if you remember, looking at the unit circle, this is -1, 0. First one's cosine, the second one's sine, so that would go to 0. And then 0 plugged in everywhere is going to give me 0, so my answer is going to be pi over 12. Now that's one petal, so if you wanted all 3 petals, you would need to multiply that times 3 to get a pi over 4 area. Okay, so again, there's going to be more complex areas, but again, just find out what your boundaries are. Try to use symmetry when possible. You could have gone from 0 to pi over 3, but since I went to the midpoint there, that would cancel in 1/2. And then you do r squared. Don't forget your trig identities. And practice always makes it easier. Make sure you look at the example where it has area common, for instance. This region right here, let's take a quick look before I let you go, is 2 boundaries. There's 2 distinct boundaries here. One is formed by the red circle, so if I were, let's say this is theta equals, I don't know, it looks like about 45 degrees roughly. So if I were to do the region area common, just to set up the integral, whatever the circle, red circle is, I would have to do that one first. And it would be the integral from 0 to pi over 4 of the red circle. It's a sine, so let's say what, 3 sine theta. Let's just make that, I'm just making that up right now as we speak. And then this one would have to be a plus, and then it would be the blue circle, and that would go from pi over 4 to this point right here, which is pi over 2, and whatever the blue circle would be. Okay, so it's really crucial knowing the boundaries and being able to graph these. So take your time, practice these graphs, okay, and practice area as well. I'll do a more complex area problem or 2 in the next video, but this is just the basic one. So I hope I've explained the concept and done the example in one shot. Okay, practice. Thank you, and have a nice day.